the cerebral cortex, this big cortical mantle that is the main thing you see when you look onto a brain. The main thing that's filling your skull, you could say, is a learning machine. And it's supported by subcortical machinery that's controlling that learning, that's modulating, that's regulating it.
Inside the brain, information is processed by neurons forming neural networks. These networks connect one event with another.
The brain is continually associating information across time. That is to say, it's continually generating constructs of inputs that relate to what is concurrently occurring or occurring across successive time. So, for example, if you train an animal to make a distinction about things in a sequence in time in which there's A followed by B, you actually create selectivity for the sequence. Neurons respond most powerfully to B when they're preceded by A. You actually see that develop in a brain.
We use the term conditioning to refer to simple types of associative learning. The scientific study of conditioning began in 1898.
One of the most influential set of findings ever in the history of the field of learning and memory came from the laboratory of Ivan Petrovich Pavlov in Russia, who had won the Nobel Prize for studies of digestion. And in the course of these studies had developed a technique for having the saliva come outside of the cheek of the dog into a pouch so that he could study the chemical content of the saliva. And what he learned one day was that the dogs began to salivate before they got the food that was going to start being digested. And he said, wait a second, what's going on?
My guess, if I were to put myself in his place, I would think, that stupid dog. He's responding where he's not supposed to. Throw him out and we'll get a fresh dog and start over again. And I tend to imagine that that might have been what he initially thought. But a good scientist is one who's able to put aside their expectations and actually see what is going on. And this is what Pavlov did.
What he learned was cues that are associated with food will come to induce the same response or a similar response, which is the salivation response. A dog can be presented with some kind of a cue, and he used such things as running water or a black square or something of that kind associated with food put on the dog's tongue, and eventually the dog would come to salivate to whatever cue was being used.
And so he dropped his work on the digestive process and salivation and began to study what he called a conditioned reflex. We now call it classical conditioning because it was the first type of learning that was studied.
Pavlov's work was really important for two reasons. One, it demonstrated that you could study basic processes of learning scientifically, and so it gave impetus to the scientific perspective in psychological science. Secondly, his principles of conditioning are applicable to many other human realms than just dogs drooling. And so, for example, human fears are conditioned. I was in my car one day and driving down the road, and a car came from the side and drove through a stoplight and hit me. Ever thereafter, as I approached that intersection, and intersections like it, because I generalized from that experience, I would cautiously look and slow down a bit. That was a conditioned emotion, and it was a Pavlovian conditioned emotion.
I don't want to do this. I don't want to get off now.
We know that one of the primary ways people learn fears is when something that they're originally not afraid of gets paired with some negative experience. If they were swimming and almost drowned, they would be quite likely to acquire fear of water in those circumstances. Some people try to discredit a conditioning theory of phobias by saying, it doesn't work for everybody. Well, we expect that prior experience, knowing that an object or situation is safe, is going to help protect you against later learning that it's dangerous.
So the classic example of Pavlov with the bell going off and the meat powder, the bell elicits salivation. Okay? Well, let's say that I have a lot of pre-exposure to that bell. Latent inhibition says that that dog will not learn to salivate to that bell just because it's linked with meat powder, because of many, many, many exposures to that bell that wasn't associated with meat powder.
Though we usually think of learning as an adaptive process, some associations made by the brain may have destructive effects.
So where do prejudices come from? Well, our cultural views or beliefs that we learn as children here holds certain things to be true about African Americans versus Caucasians. Now, you might be educated and know those to be inaccurate, but you still have that associative structure in your head, and that associative structure can influence your behavior in ways that are quite subtle.
What the definition of learning is relatively permanent changes. Just because you're conditioned doesn't mean you can't become unconditioned, because if you learned how to do this, then you can unlearn how to do it and do something else.